Okay. So again, thank you to be here. So this is the thing that I would like to propose to explain today. Some of them I will explain them more lightly. And remember that this is a lot of information. So I will highlight what is the important information here that you should know. And one is something that you really don't have to know. And if at some point you know it's better, but you really don't have to know. Again, I'm going to record this lesson. So if at some point you ask me the recording, the video, you always can remember all these things, okay? So just to have it. So just don't worry if you feel that you need to absorb everything, because it's not like that, okay? Indeed, you need to absorb only 4 or 5 ideas, okay? Yeah. So what is Linux? So let's start with what is Linux, because that is the most important thing, no? That you are going to interact with something that is called Linux. And Linux, to know Linux, you need to know a little bit first what is Unix, okay? And Unix was an operating system, okay, made for computers that was developed in the 70s, long time ago, with one idea in mind, that needed to be multi-user and multitasking. And that is the main difference with DOS and then Windows, okay? Windows was associated to a personal computer. So when they were designing Windows, they were expecting that only one person will use that computer. So that means that that person will be responsible for the security and everything else. So they didn't thought about having more people using that computer. Meanwhile, Unix was designed with this idea in mind that you will have multiple people accessing to a computer and running several processes at the same time. So these systems are quite good trying to handle that. Okay, so that is one of the reasons. So, and basically, you need to keep in mind that when you are interacting with a computer is a physical system in which you have a lot of a microprocessor that is moving zeros and ones. That means I have electric energy or not, okay? But of course we don't see that, no? So an operating system is this part of the system that interact with the hardware. In other words, it's the thing that tells the hardware, okay, so if I say 2 + 2, what will be the result? Okay, so that will be the operating system. At the same time, it's the part of the system that also controls the graphical card, and you can see something in the screen, or even can detect the input that you are giving to the computer through the keyboard. On top of that is when you build the applications, any programs, and then finally is you. So as I said, between you and the hardware, you have 2 layers. One of them is applications and programs, and the other is a more basic layer that is this operating system. So, as evolutionary biologist, I like this picture, and it's maybe not nice, but I like it because at some point Unix started to evolve in different systems. Okay, so this is a phylogenetic, let's call it phylogenetic tree, kind of a phylogenetic tree of Unix systems. So Unix evolved. And evolving in a lot of different systems that you can see. Most of these is something that you will not know the name, okay? Because they are for companies. But the ones that you may know at some point are MacOS, that is from Apple, and then GNU Linux, okay? That was designed by Linus Torvald. And why this is important means because the operating system in your Mac computer, if you have a Mac computer, is the same or is similar. No, it's not the same, but has the same basis that the operating system in Linux. No, if we are thinking in organisms, in a living organisms, it's like in some ways they are plants. Okay, maybe one of them is a gymnosperm and the other is an angiosperm. That would be if you want to have a plant context, or you want to have in an animal context. It's like to have a mammal and a fish. In some ways, there are a lot of common things in these systems, okay? So that is an important thing. It's why if you have a Mac computer, sometimes it's more easy to interact with Linux than just if you have a Windows computer, okay? So when Linus Torvalds starting to design Linux, he also have two things in mind. One of them was to convert this operating system that was designed for big systems to personal computers, so everyone could install in their own computer if they wanted. And the other was that should be free and open source. Okay, and I will talk about what is free later. But what is open source means that if you want, you can go to the code, okay, to all the coding, all the programs that are built in this system, and you can read it if you want, okay? Meanwhile, you cannot see what is inside Windows code, okay? The operating system is something that is closed, and you cannot open it to see what is inside, and of course, you cannot modify that if you want. Okay, so that is Linux, no? Linux is an evolution from Unix systems with several commonalities and with something in mind that is open source and free. Then you have the thing that is called Linux distributions. And this when this is starting, some names will start to ring you a bell. Linux distribution is when an operating system at the end is a collection of programs, okay, to interact with the hardware. And a collection of applications too, like a web browser. So a Linux distribution is just a cluster, a system in which you have some specific applications, okay? So as I said, no, a Linux distribution is a Linux kernel that is the operating system, a set of libraries, and then some utilities. So for example, some typical Linux distribution is Ubuntu. I guess that you know Ubuntu, when you avail Ubuntu at this point. So Ubuntu is a Linux distribution that, for example, uses Firefox as a web browser. Meanwhile, Debian is a complete different Linux distribution that uses I2TA2020. Ubuntu is a program, is an operating system that can use some proprietary software if they want it, and Firefox is a proprietary software. Meanwhile, Debian, when they designed Debian, they decided that all the software should be public and open. So they couldn't not use Firefox, so they developed a different version of a web browser that was called I2TA20. And of course, you have more than 600 distributions of Linux. No? You have things like Fedora, SUSE, Mandriva, Gentoo. You have many of them. Some of them even are designed for some specific applications. So you have a BioLinux that contain a lot of biological programs, or even you have applications, you have Linux distributions that are designed to test security, okay, like Kali. Other thing that you need to know about Linux distribution is that you have two types. You have the commercially backed distribution or community-driven distribution. And the difference is, even if both of them are free, in one of them you pay, you have a company that you can pay to maintain your system. And in the other one, no one maintains your system. You are responsible for your system, but then you have a community that are working for free, just helping other people, okay, to have this operating system working in for them, okay? So different model systems. So as I said, Red Hat is one of them, or Debian is another one. So you are interested to this too. This is an example of a company-driven Linux distribution, and this is a community-driven distribution. Okay, so that is Linux. Questions that you may have about the operating system as Linux. You know now what is an operating system and what is Linux. Okay, so you don't have questions. I'm going to go to the next step, that is the terminal. So traditionally, computers, you have the thing that has been called the console. And the console, or computer terminal, because in some ways it's similar, has been used to interchange this term, even if it's confusing, is a text entry and a display device. So keep in mind that you have a computer, and when you have a computer, the computer shows you information, and you need to introduce information, okay? So you have an input, how you introduce information, and an output, how the computer is showing you information. How you introduce information to the computer is mostly through the keyboard. Of course, you can copy files from one place to another, but mostly is the computer. So the computer is how the keyboard. So the keyboard is how the computer receives information from the user. Meanwhile, the display, the screen is going to show the user an output. Okay. So as I said, if you type something like "show me the files in this directory," it will show that in the screen. Okay. So that is a physical. So the console is a physical device consisting in a keyboard and a screen, input and output. Okay. So mostly, when you have an operating system, basically you have a standard input. As I said, maybe a file, maybe it's a command that you write to interact with the computer. And then, and this is important, you have always two different outputs, okay? It may be mixed, it may not. Sometimes you have only one of them, sometimes you have the other one, but in most of the cases, the computer is going to give you two outputs, okay? One of them is the standard output, and the other is the standard error. The standard error is going to inform you if you have some problems running a program, or, for example, what is the status of running a program. Meanwhile, the standard output is the expected output of the program. So you are processing information. Let's say you are analyzing some data, and you are expecting a summary. The standard output will be that summary. Meanwhile, the standard error is if you are running that program and the program finds an error, that will be printed in the screen as a standard error. In the screen, when the computer is showing these outputs, you don't see the difference, okay? You will see that something that is printed that is the standard error, or something that is printed that is the standard output. You don't see the difference, but they can be recollected. They can be redirected to a file in different ways. So that is another important point here. So that is how we interact, but of course, we don't understand zeros and ones, okay? We cannot interact directly with the operating system. So in order to do that, we have the thing that is called a shell. So a shell is a program that interprets commands to give you inputs and outputs. So it's an interface between what you give to the computer and what do you get from the computer. And the shell, you have two different types of shells. So you have a graphical user interface, also called GUI. Okay, it's like, for example, this operating system from Mac. And then you have the command line interface, also called CLI. That will be just something where you write commands and you execute commands. This has some advantage on this. So of course, a graphical interface is more intuitive, okay? But it has some problems. So one of them is you use more resources in order to build this graphical interface. And the second one is for some process, you cannot batch your processes as well, or you cannot automatize your process, okay? It's more difficult in a graphical interface environment to tell the computer, I want you every day to open this window and execute this program on these files. Meanwhile, with a command line interface, it's more easy to do this kind of processes. So the command line interface, and will be the system that you will be using, is a mechanism for interacting with the computer, the operating system or the software, just typing commands to perform a specific task, okay? These commands are being run in the thing that we call a terminal or a terminal emulator. So if you are have a Mac, you will have a terminal. You have a Linux, you will have a terminal. You have a Windows computer, you will need to install the thing that is called a terminal emulator, like Mova Xterm or Pathe. The most common terminal program, and this is a name, okay? You have a lot of terminals, type of terminals. It's like having a lot of different type of cars. So you have different brands of cars. You can have a Ford, or you can have a Seat, for example. So in the same way, you have a lot of different types, different brands of terminals, but the most common one that we are using is the bash born against shell. Okay. Don't worry, because as I said, Bash is why we say we are writing in Bash, because this is the most common interpreter and program for the terminal. So when you connect to the server for your first time, and if you didn't do it, that will be the first time that you need to do it, you will have a message, a greeting message saying, welcome to this computer, and then a greeting message, as you can see here, mostly when was the last time that you log in and from which IP. And then you will have another line when you can write a command, when it's going to tell you which user is working already in the terminal, which is the name of the system, the location, and in this case, this location means home. And then you will have this blinking cursor waiting you to receive an order, waiting you to have to write a command. So that is the first thing that you should see. So you already are not connected to the server, you can try, because that is the thing that you should expect to see. Okay? So how many of you have connected to the server already? Or how many of you are already in the server? Okay? I can see several, perfect. I can see a lot of raising hands. Happy to see that you are connected to the server. Okay, so you are connected to the server. If you type the command echo space $, and in uppercase shell, is going to tell you which shell do you have. Okay, and that will be your first, well, probably it's not going to be your first command, but in this class will be your first command. Type echo space shell. Okay. And if you want, just copy and paste the results in the chat. Hopefully every one of you should have the same message. Exactly. So it's telling you, yeah. Sorry, Gaetano, the thing I'm saying is type in the terminal or in the terminal emulator that you have, you are connected to the server, the command echo space $shell. And as you can see with most of your colleagues, the thing that you should receive back is this /bin/bash. So it's telling you that the shell that you are using is bash. And the program is located in a directory called bin. Okay. Okay, perfect. Yeah, so almost there, almost there. So all of you just wrote your first command, means that, yeah, I mean, the rest of the Linux is going to be easy, okay? Just few details, but yeah, it's not going to be more difficult than that. Perfect. So now that you have this echo $shell, okay, let's go and start to talk about files and directories. As you can see, the thing that this program was printing is not only the name of the program that you can see bin bash, but also where this bin bash is located. So you have a /bin/bash. What means that? The thing that is meaning is dash, slash means root, so it's the beginning of the file directories, and then inside root you have a directory that is called bin. If you go inside that directory, you will have a program that is called bash, that is the program that is being used by the shell. Okay. So let's go to talk about this with more detail. When you have a graphical interface, all of you know that, you open a screen and you will have, for example, as you can see here, files and directories, and if you click one of the directories, you can go inside. Okay, so that is an example about how the directories look like. Okay, and then you have these directories. It's the same thing, for example, if you are working with a kind of a Linux, Windows environments, or even with a web browser. No? So you have some system that is going to allow you to navigate through the thing that we call file system. So the file system is the organization of your files in your operating system. So you have different ways to navigate through your file system. And the thing that is important when you are thinking about accessing to the file system are 4 questions. First, is the file access convenient? So it's easy to access, or everyone can access? Should everyone access? So that is the question that a file system should resolve. What about the repeated access? If I need to access several times, it's easy to do that. What about the speed? How fast will be to access several times to different files? And then if need to be interactive, need to be able to be used by different platforms. So that are the first questions that a file system should be able to handle. So when we are thinking about graphical interface and command line interface, you still have some structures that are the same. So the structure is the same. How this structure is interpreted and is shown to the user is different, but the structures will be the same. So for example, if you have a system, you still have roots, and then you still have all these different volumes, and then you have home, and then you have all the different directories for home. Okay, so that is a common thing. Okay, so that is how file systems is building the system. But as I mentioned, the thing that is important, and this is common for Linux and for Mac, for all the Unix system, is that all the file systems start in the thing that is called root. And from that, you build the rest of the system. So this would be an example, no? And of course, you can interpret the same file system in some way. So Mac, for example, you have the graphical interface that you can see. So this is all the bioinformatic projects in which I'm working with. So this is how looks them in a graphical interface. And this is how look them with a command line interface. Okay, so that's just the same. As you can see, some of the information that you can see is the same. Some information is different. No? So here I have an extra layer of information that tells me how easy it is to access to these files. We will tell you about permissions later, and who owns the file. So that is an important thing too. So, as I mentioned, it's important to know 2 differences when you access to the file system. The first is when you log in into your system or into the server, you are going to enter. You are going to in the thing that is called home. So the enter location is always going to be the thing that is called home. Okay, that is where the working directory is going to appear by default. Okay, I'm going to use indirectly where you are or the working directory. Okay, so that's the same thing. No, when you are in some part of the system, it's the same thing to say my working directory is in this part of the system. So when you enter in the system for the first time, you will be at home. No? So for example, in my home directory could be in the server, will be something like Bombarelli A, or specifically root data Bombarelli. So it's where my home directory is in the server. Okay. Meanwhile, the root directory is everything that starts with this slash, so slash bin, slash bin, slash dev, slash data, slash one. So all directories are in the root. So it's a top level directories. Okay, so it's the beginning of everything in the file system. Okay, so when you log into the system, remember that I told you that in the terminal, this is going to show you the location. No, after the system, you have a column, and after the column, you have something that indicates where you are. So when you have this ampersand, the thing is you are in home. Meanwhile, when you already have this dash, slash, you will be in root. Okay, so that is an important point. Okay, here you are home, here is a root. If you are in a different place, it will show you, okay, the whole path. So that is the file directory. Let me move to absolute and relative path, and then I will stop for questions. So when you are in the file system, all the files and directories in your file system will have a location, okay? But at the same time, remember that I told you that you are in a working directory, okay? So when you need to locate a file or a directory, there are two ways to locate that. One of them is to use the thing that is called a relative path to the file, and the other is to call an absolute path to the file, okay? And the example is simple, no? Imagine for all of you that you are now in the Department of Bioscience building, okay, in Golgi 17. If I ask you, go to this office and take a book, okay, go to the office and take a book. If I told you, to all of you, go to the office and take a book, making the assumption that you are in the third floor, you may go to this office, find a book, and take it. So imagine that you are the computer. So you go to this office, take the book, and I don't know, read a sentence. So me is the user, me giving you the command, going to the office is the command, and you are executing the command as computer, going to a different part of the file system that is this office, find an item, and read it, okay? But in this case, I'm using a relative path because I'm assuming that you are in the third floor of the Department of Bioscience building. For all of you that you are not in that building, let's say that you are at home, or you are in veterinary, or even you are in a different floor in the same building, if you executed my order, you probably are not going to find this book. Maybe you are going to find a different book. So your order will fail because you are not going to find the thing that I'm telling you, because I'm giving you a relative path. So that is a relative path. An absolute path, if all of you, I tell you, the book that you need to find is in the planet Earth, Italy, Milan, Golgi 6, Department of Bioscience, third floor, Tower B. If I give you all these details, you are going to be able to find the book, and that will be the absolute path. So for computers, it's just the same thing, okay? It's just the same thing. You can specify the location of a file or a directory with an absolute path, starting to describe where is the file from the root of your file system, or you can describe where it is from the working directory where you are. That is the relative path. Why this is important is because 80% of the people that fail working with Linux is because they are trying to run programs specifying the wrong location for files. Okay, I'll repeat it again. 80% of the people that fail working with Linux is because they fail to specify the location of the file when you are trying to execute a command. So if you are trying to run a command and it fails, read the error first and check, maybe I'm not using the right location, okay? So that is important. And when I tell you that you need to know 5 things from this Linux class, this is the first and the most important one, because otherwise you are not going to be able to run any command. So again, you have absolute path and relative path. Relative path works from the computer. In most of the time, you are going to use relative path because are faster, okay? So it's why everyone sometimes uses a relative path. And this is a good example, no? If I'm working with in my directory, I have this directory that is RNS pliego. This will be a relative path, or this will be the absolute path. No, absolute path is starting from roots all the way down until this directory. Remember that in the login system, username, system, ... and location. So I'm in the directory called avocado. and then I'm running a command using this target. If I will be in a different directory that is not avocado and I'm trying to run this command, it's going to fail, okay, because this is a relative path. Meanwhile, in this case, I'm in avocado, but because I'm specifying the all path, the absolute path, not matter in which directory is my working directory, in which directory I am, that I can run this command and always is going to work, okay? Okay, so there are important commands associated with file navigation. And the commands that you are going to learn, and let's start to type again other commands, is going to be pwd, that is print working there. So let's start with this one. All of you type pwd and copy the output and paste the output in the chat. That will be your working directory. So that should be your home, because that is the first directory where you are. Okay, so you see that all of you are going to share this storage user RNA-seq unimi, okay, and then change the name of the directory. So yeah, Gaetano, I can see that you are not in the server. Probably. Yeah, and then the same thing. You are right now. You are not in the server. You are in your local computer. Okay. For all of you, well, it's fine. For all of you that you are outside, as soon as you can enter in the server, it's fine. Don't worry. Okay, so you can see the trends, no? So you can see that that will be, yeah, the working directory. Okay, yeah, please, the ones that are outside, please try to connect again. This system, the terminal, okay, as well as mobile extern, is going to kick out you of the server after some period of inactivity, okay? So after 5 minutes of inactivity, you are going to, the system is going to throw you away, okay? So keep that in mind. Depending sometimes of the systems, or depending of your connection, but keep in mind that sometimes the server is going to throw you away. Yeah, you need to reconnect. Okay, perfect. So that is the printing working directory. So it's telling you where you are. And of course, it's printing the absolute path. So you can see from root, storage, and then the rest of the system. Okay, perfect. So if you want to change the working directory, okay, the location where you are, the command that you need to use is cd. That means change directory. So you type cd space and then the name of the directory, and you will be able to move from one directory to another. If you type cd space slash, you will go to root. Okay. If you type cd space this ampersand, you will go to home. If you type cd space dot dot, you will go one directory up. Okay. And then I'm going to ask you what to do if you type cd by default. Okay, so before that, all of you type cd space. Yeah, indeed, that is, yeah, Tommaso answered the right answer. So type cd space dot dot. Okay, and now type, and after you type that, type pwd. Okay, it's going to tell you that you have changed the working directory in which you are, and you should go one directory up. Okay, so just do that. Type cd space dot dot. Okay, and then pwd. For all of you, I mean, 2 or 3 or 4 people of you, just copy the results and paste in the screen, so in the chat, so everyone will see the difference. Okay. Perfect. So you can see, no, that's you are moving up, and all of you are in this directory that I created for everyone. That is just one app. By the way, I can see that some people just move 2 apps instead one, but it's fine. Okay. So you see that, no? So now if you type CD with no options, with no any other options, so type again CD with no other options, and then PWD. So you will see that you will go back, as someone said, to home. Okay. So you have navigated in the okay, perfect. You see, the people are going back to home. Okay, so now you know more or less how it works. It's simple. CD to move one directory to another, and PWD to know where you are. So are the 2 important commands. 2 other commands that I want to tell you to know are mkdir to create an empty directory, and you will use during the exercise, and touch to create an empty file. Okay. Okay. Perfect. Do you want a break?
Actually, I have a question.
Okay, perfect. Yeah.
I don't get the difference between home and root. I mean, root, I think that is the path within the computer.
No, no. Yeah, roots and home are 2 different locations.
Okay.
So in the system, roots and home are 2 different locations. So home is the directory, or the location of the directory in which you appear when you log into the computer. And of course, you own this location. Okay. So let's suppose, let's be simple, no? So in your case, home is where you live. No? Every morning you wake up at home, hopefully. Meanwhile, root is the beginning of the system. It's a different location that is the beginning of the system. So in your case, root is Earth, planet Earth. That will be the, let's supposing the planet Earth is the beginning of the system.
Okay.
Yeah.
And my second question is, I can't find on the keyboard the key for the symbol home.
Okay. That is another thing that I forget to mention. The server has a keyboard layout that is the American keyboard layout. Okay. I'm pretty sure that most of you has an Italian keyboard layout. Okay, yeah, sure, no problem. Yeah. Yeah, for the people that have, if you have some problems, send me an email, okay, telling me what are the problems that you have, and maybe I will be able to resolve it, okay? And yeah, don't worry. Okay, so, yeah, keys. So the problem is that your keyboard are not going to have all the keys. So, but don't worry, because as I said, home sometimes has this ampersand symbol, or just if you type CD with no options, you will go back to home. Okay, so that will be one option. Other option is to type $home in uppercase. So you type $home in uppercases, that will be equivalent to home. So yeah, the problem is that some keys are not going to be available for you in your keyboard. So you have 2 options: copy and paste the symbol. On time to see, you have some shortcuts, that combination of keys that are going to produce the character that you need. Okay. So most of the time I just copy and paste. Okay. So for example, yeah. Okay, good. Okay, going back to that. Do you need a break of 5 minutes before I continue, or should I continue until 11:30?
I'm fine to continue, Ari.
Okay. Okay. So if no one need to go and take some coffee, I will continue and then we will stop at 11:30. Okay. So let's go to the basic command structure. So remember that when we interface with the system, as I mentioned before, you have the shell. When you write the command, you have a standard input, and then this standard output and standard error. But of course, you need to type a command that is going to interact with this standard input in order to produce something, because the system needs to understand what is the thing that the system have to do. Okay. So the anatomy of a Linux command is like a sentence. So first, you have the command. Then you have some options. Okay, you may have these flags that can be short forms or long forms. So this will be the same. So you say -L or -H will be the same that -list or -human. So you have short forms or long forms, depending. Short forms, the problem is that it's not intuitive what is the thing that they do, but of course you need to type less. And then you have arguments. Okay, the arguments is the target of the command. So you type ls and then data bombarded list is going to run the command ls on this file. Okay, so that is basically how the commands work. Remember that arguments, okay, and flags should be separated by space. So the space is the one that tells that. Okay. We are going to skip the exercise because I already sent you some exercise for later. So when you're writing commands, there are some special characters that have some special meanings. So for example, a space, separate commands and arguments. Pound, the hash, is a comment. Semicolon is a command separator for multiple commands. You want to run multiple commands in the same line. Dot means source of the command or a file name or the current directory. And then you have a lot of different ones, okay? But the important ones that I want you to remember, because you will use it, are space, of course, okay? Double dots, because it's the parent directory. Single quotes, because it's going to interpret literally something, and I will tell you why later. Slash, because it's the file name separator, okay? And then these characters, because are going to help you to radiate inputs on output, or the pipe, because you can pipe output between commands. So sometimes you can run a command and pipe the output in a next command. Okay, so the output of one command will be the input of the next command, and then you can pipe again, being the output of that command, the input of a new command, and so on. So the thing that you use to do that is this symbol that is pipe. Okay, and I will tell you about that thing later. So why these things is important? Okay, so remember that you may have, imagine that you have a directory that is called Solanum Lycopersicum, and you have a space. If you type ls Solanum space Lycopersicum, the thing that the system understands is that you are running ls, first of Solanum and second in Lycopersicum, but not that you have a directory that is Solanum space Lycopersicum. So it's important for the var to interpret to have separators. So you have two options to give to the system this idea that you have here a space in the name. One of them is you use single quotes. So you say ls Solanum space Lycopersicum is going to understand that this literally is a space for the name. Other option is to use backslash, that is an escape. It's called escape. And then when you put an escape, everything that comes after the space is going to be interpreted literally and not with a special function. So you say backslash space means space. It doesn't mean separator between arguments. You say backslash, for example, dot means a dot doesn't mean source command or something like that. Okay, so this is the thing that's called escape. So you have two options to specify that you have a space in the name. Other thing that is important is this wildcard. And wildcard is important because it represent anything, okay? That can be confusing, but what means anything? Imagine that you have a directory with a lot of 120 files. Of these 120 files, you have 20 files that are .txt. If you want to move this file from one location to another, or to copy this file from one location to another, you don't want to type 20 times the name of the file. So potentially, one option that you have, if you are going to copy them, is to use cp, that is the copy command, space, and then wildcard.txt. So wildcard means in this case, whatever file, whatever name are you targeting, and then you have this .txt, so means .txt at the end. So in some ways, as I said, it's kind of the joker when you are working, when you are playing cards, okay? It can take any value, okay? So in that case, if you do, as I said, cp space wildcard.txt and then a new location, you will copy all the files that end in txt. Be careful, because if you use with rm, that is to delete files, you may delete all of them too. So you need to be careful how you use that. So this is example. For example, you use d star p, you are going to target all the files and directories that start with d and end with p. Or you say star txt, you are going to target all the files that end in txt. Other command that is important is man. Okay, man means represent manual. So you can type manual and then the name of a command, and then will open a new window, a new screen, in which you can read the manual of the command. You need to go out, you can type Q and you will go out of the manual. And other command that is important is history. So you don't know which command did you run. If you type history, you will see that you are printing what are your last commands. So type history now and see the effects. You don't need to print, you don't need to copy in the chat, but just do it. Type history and you will see all the commands that you ran. This is a buffer of 1000 commands. So if you type 1001, the first one will be deleted and then you will see only the last 1000, okay? Okay, so that is for command structure. Okay, so section 3, 4, and 5 are essential. So all these commands that I told you are also essential. So when I told you you need to learn 5 things, let's start with absolute and relative path, the most important one. The second one are these commands that I told you. So you need to know about CD, you need to know about wildcards, and so on. I didn't mention, but I forgot to say that, of course, names are case sensitive. So it's not the same to say uppercase Solano, uppercase S Solano, than lowercase s Solano. Okay, they are not the same thing. So this is the thing that is called case sensitive. So when you are typing commands, remember the structure is the name of my command, a space, any flag that I want to use, or any argument, separated by a space. Okay, so that is the second more important thing that you need to learn. And the third, as I said, is these commands that I told. Okay, so let's go to users, groups, and permissions. And as I said, the importance, of course, of these lessons decreased once we move. So user groups and permissions is important, manipulating files is important, and shortcuts is important. And then the rest of the thing that I'm going to tell you, you don't have to learn that, okay? It's important that you know where you have the information, but you don't have to learn. So user groups and permissions. Remember that at the beginning I told you that Unix systems or Linux systems are multi-user systems. So it means that more than one people can access to the system. So in order to protect people interacting with each other, okay, the thing that we have is permissions. So when you type ls, you should see something like this, okay? And the first section that you can see here define permissions, and the second section that you see here define who owns the file, okay? So these are the permissions. These are the number of links that you can see. So all these things that you can see is the thing that you see when you type ls space -lh, okay? So these are the number of links that you find, files, the group name, the username, size, date, and the name of the file. Okay, so that is the information that you get. So, and important here are permissions, group names, and username. So what this permission is telling you? Well, depends. So you have a first letter, okay? The first letter can be dash, D, L, C, S, P, or B. For regular purposes, forget about the rest, link, special file, socket, is something that usually doesn't appear. So most of the time you are going to find the dash, that means you have a regular file, or D, that means that you have a directory. And then you have 9 characters, okay? 9 characters that can be clustered by a group of 3. So the first 3 refers have some meaning for the user that owns the file, the owner of the file. The second 3, so means 4, 5, and 6 character, defines some information for the group that own the file. And the last 3, that will be 7, 8, and 9, define information for the rest of the people that are not the user or are not in the group that own the file. This can be R, W, or X. Okay, so each of these 3 characters can be R, W, X. R means that you can read the file. W means that you can write the file, or X means that you can execute the file. So execute the file is not only for files that can be executable, but you need to access inside the directory. It means that also the directory need to be executable. So just looking into this example, we can see that, for example, for this file source that you can see here, the owner, that is me, can read the file and can write the file, but cannot execute the file. Also, the group, that is a group made by me, myself, can also read the file and write the file, but cannot execute the file. And the rest of the people in this system can read the file, but cannot write or execute the file. When we are looking for the directories, it's the same, but the directories, as you can see, they can be executable because it's in order for me to access inside these directories, need to be executed. So that is this example. No, here I have another example about this will be readable for everyone. In this case, it's readable for everyone, but then readable and executable only for the owner. Or in this case, it's a directory that is readable for everyone and writable only for the user and the group. There are 2 commands that you can use to change the directories permissions. So the first is chowner, and chowner can change the owner and the group. So for example, I can change the group from myself to everyone in the server, or only for my laboratory users. So you can change, depending on the group, you may define that. And also you can change permissions. So to change permission, you have 2 ways. One of them is with this code that you can see here. So for example, you can say, I'm going to change for user, I'm going to make positive reading. So you say positive R, and then the name of the file, and you will change the file to be activated of R for all for the user. Again, you have user, group, or all from, I guess, that the rest of the world. You can, plus means you can enable, less means you can disable this permission, or equal means you leave as it is. And then you can say the permission line changes read R, and readable, W of writable, and X of executable. Also, you may have some numeric code. So the option is you can use chmod with 3 numbers, and each of the 3 numbers means the sum of those. So you use 0 means you disable that part. If you use these numbers means you enable. So for example, If you want to make, so this code here will be called by readable is equivalent to 2, writable is equivalent to 4 is for readable, 2 for writable, and 1 for executable. So you want to make a permission like this, will be 4 plus 0 plus 0. So the first number here will be 4. Here will be 4 plus 0 plus 0. The second number here will be 4 again. And here will be 4, 0, 0. The third number will be 4. But for example, for this one will be 4 plus 2 plus 1. So the first number will be 7. 4, 0, 0. Second number 4. And 4, 0, 0. Second number 4, 2. So you want to change a permission of a file to this kind of permission will be using the numeric code 744. Okay. The other important thing about permissions is that sometimes you may have, so not everyone can have permission for everything. So the Linux computer has this system that is sudo. So sudo is a program that allows the user to run one administrative command. That means you can do anything. Yeah, the number 4, 2, and 1 are standard. So sudo allows you to run one command as an administrator. So, and not everyone is in the group of sudo. So no one of you is in the group of sudo. But for example, if I want to run a command as an administrator, for example, to delete a file that is protected or to change the permission of a file, I can do it with sudo. Sudo is also, for example, used to install programs. Okay, fine. Okay. So that is for users, groups, and permissions. Let's talk a little bit about manipulating files. So some recapitulations about the commands that you use for move files. To find the present working directory, remember pwd. To change the working directory, cd. And to list the files in a working directory, ls. Okay, so that's the command that you already know. Less, for example, can be used to open a file and see what is inside. So you type less, you will open a new screen in which you can navigate with the arrows and you can see the content of the file. If you want to go out, you type Q. If you type space, you can scroll forward n lines, that is the number of the screen. If you type less space dash n and then the name of the file, will open the file in the file number that in the line number that you wanted. And then, it will open the file with an item that tells you what is the number of lines. And then you type plus n, and then it will open a particular line number. So you can open the file in some specific place if you want. Other important commands are head and tail. And don't worry, because you are going to use these commands on the exercise, okay? So head is going to print on the screen the first 10 rows, and tail will print the last 10 rows. If you use them with the flag -n and then a number, it will print a different number. So you will say, for example, head space -n 20, instead 10 lines is going to print 20. Cat can be used to combine multiple files. So cat is a command that you can use to print the content of a file in the screen. But you can cut one file and then another file. So there is this symbol, and be careful, this is an important symbol, that allows you to redirect the output of a file, of a command, into a file. So you say cat file1, file2, greater than, and then a file. The thing that's going to happen is that cat is going to take the content of this file and is going to print in the screen. But because you are using this, it's not going to print in the screen, but this is going to redirect this into a file. So we'll print the content of this file in this file. Then cat, once finished with this file, will execute the same thing on file 2 and will add everything to this file. So in other words, if you use this command, you are going to merge this file, and then at the end of that file, I'm going to merge this other file in a new file that is called combined file. Okay. Move mv can be used to move a file or to rename a file, okay? Depending if the output, if the second, so move is move one argument and second argument. If the second argument is a directory, we'll move the file to the new directory. If the second argument is another name, we'll move the file to, we'll change the name of the file, okay? We'll rename the file. Copy is to copy a file. So move is you change the name or you move the location. Copy is you copy. So you still keep the original one. And again, so this is an example, no? So you have copy and then one argument and the other argument. So the first argument tells you what is the input that you want to copy, and then the second argument is you want to make a different names or you want to copy in a different location. Touch is a command that you can use to create empty files that sometimes can be useful. And mkdir, as I mentioned before, it can create new empty directories. Meanwhile, rmdir is going to remove an empty directory. And I already mentioned that you will see that in the exercise script. Last one, I think, rm is going to remove a file, is going to delete it. One important question, well, one important note on those. When you use rm to remove, you are going to delete the file from the system. You are not going to move the file into a garbage directory, okay? So you type rm and then the name of the file, that file disappears of the system forever, okay? So be careful when you use rm because it can remove the file from the system forever. Yeah, other thing is when you need to locate a file. So there are two commands that you can use, that is locate or find, you know? Depending, locate is to find a file quickly, to find a file quickly, not resting in all the system. Meanwhile, find is to find a file with more options, but still slow. Okay, so these are the list of the commands. So sometimes when you are working with these things, it's useful to have this. So the thing that I did when I was learning Linux is I printed this and I put in my desk to know what are the commands that I have to use, okay? So that these common commands that you will be using during the whole class, okay? Again, and then I'm going to skip the exercise. One thing about the commands that I also want to mention is that you can control the standard output. Okay, remember that you can have you can print the results in the screen, but you can redirect them to a file if you want. So to redirect into a file, you have two options. One of them is this greater than symbol that creates and add the content into a file. And be careful because when you say greater than as it is, you are going to overwrite the file. Okay. So you overwrite the file, you will lose the content forever. So that be careful. Or the other option is greater than, you use twice, that means append. So you use with a file that already exists, is going to append the content of these commands at the end of the file that already exists. So it's not going to overwrite anything. And a very important symbol is this symbol pipe, because it's going to pipe the standard output of a command into a new one. So you type something like ls and then a target is going to print an output, but then if you say grep 01, the output of this command is going to be the input of the next one. Other commands that may be useful, and don't worry, is something that you can keep in mind. You don't need to learn about them. You may use some of them during the exercise in a controlled way. Are commands like grep, that is being used to print matching lines. Cut, that is to cut columns. Sort, that is to sort rows into a file. Unique, that is to select unique words in a file. Set, and it's a very complex one, can be used to replace occurrences as you can see in this example. And then the final one is WC, that is to count walls or lines or depending. And you will see some examples during the exercises. Okay. So that is the important core for Linux. So at the end of these 3 days, you should feel comfortable with all these things that I explained. And I know that is a lot of information, so feel free to take the time that you need to digest them. I'm going to talk very quickly, just for your reference, okay, about shortcuts, environmental variables, monitoring resources, networking, and installing programs. You are tired because, as I said, I can understand that this can be too much with no break. If you want to disconnect, it's fine. Remember that at some point I will stop the recording, so you always can access to this information later on, just going to the recording. So if you need your time, don't worry, just take it, okay? Just remember that in the last 5 minutes before 11:30, I will explain the exercise, but just keep that in mind. Okay, so shortcuts are a combination of keys that you can use to execute some functions. So remember that you have, this is the keyboard, and then you have character keys, as you can see here. This is a English keyboard, I think. So this is the character keys, and then you have modifier keys that are the ones that you can see in pink, or then system and graphical interface keys, that is the one that you can see in orange. Okay, so you can have a combination of keys that is a modifier key and then a character key to do something special. So for example, the first most important thing is tab. So when you are typing a command and then you need to complete you want to auto-complete a name of a directory. If the directory exists, you, for example, type cd space e and then you push tab. If exists a directory that starts with e, will auto-complete the name, so you don't need to type everything. Okay. If you have two options, for example, imagine that you have test 01 or 02. You type test, for example, less te, and then you put tab, it will give you two options. So if you enter with a key some character that define which option do you want, is going to finish that option. No, sorry. In this case, imagine that you are in a directory that you have test 1 and test 2. You type less t, and then you type push tab, is going to complete until test 0. And then if you push tab again, it's going to tell you, okay, what do you want? You want test 1 or test 2? If you type 1 and then push tab, will complete that option. Other important one is the up or down arrow, because it's going to let move in history. So if you type the arrows up and down, you can move to through the history. And then you can execute another command if you want. And this is a summary of all the different keywords, or different combinations. The one that I tell you that is more important, or the most important one, is Control-C, okay? Control-C, if you are running a process and you feel that the process that you are running is wrong, you can stop the process, you can kill the process, just Control-C, okay? That is very important. That is shortcuts. Remember, the shortcuts that you can use, or it's going to be more useful for you, is going to be the tab, the arrows to navigate through the history, and Control-C to kill a process that you don't want. Environmental variables is the system has some variables storage. So it has some things that are already defined by default. So for example, remember that at the beginning of the class, I told you about $shell. That's one environmental variable. $home is another environmental variable. So there are two types of variables in a Linux shell. One of them is these system variables that you saw. And the other one is user-defined variables, like something that you can define for some specific occasion. So you say something like d equal 1. You are creating a variable that is d with the value of 1. The system variable, the most common one, is the one that you see here. So you type echo space $, and then any of these names, you will print the value of the system variable on your screen. Okay, if you are curious. System variables can be set and can be printed. So set is print the commands for setting environmental variables. Meanwhile, env prints all the environmental variables that have been defined in your system. These are an example, but of course you may have hundreds of them. So M will print all of them. Echo is a command can be used to print things. So you say echo space $. Dollar means I'm calling the variable. And then the name of the variable, you will print the value of the variable on your screen. And the final thing is export is a command that you can use to create new environmental variables. So that will be a good example. You say export path equal a directory colon. That means another separation, and then $path, that will be the old one, will add the old path value to the new one. I will talk during the program about the path variable. As I said, I'm not going to tell you about that because that's already much information. Okay. The other thing that I mentioned is that you also can create your own variables. So if you want to create your own variables, as I mentioned, you type the name of the variable that you want to use, equal, okay, and then the value of the variable that will have you, and then you can use the variable when you want. And set will unset the undesired variables. And the last one that is interesting is source. Source is a command that you can use to execute commands from a file. So you have a lot of different variables that you want to set up, and you put them in a file, and you want to set up again. The only thing that you need to do is type source and the name of the file, and source is going to read the file and execute the commands there. So if you have commands to set up variables, you will execute those too. Okay, so that is a summary of system variables. Questions? Are you still there?
Yes.
Okay.
Yes.
Okay. As I said, okay, so let me finish with this. If at some point I'm talking to no one, it still is fine, because as you remember, I told you that you can take a break if you want, and as soon as we have the recording. Okay, so last thing that I want to mention is monitoring resources, because when you are running programs, it's important to know what is happening in your system, okay? If a lot of people is using a lot of memory, maybe you should know that. Or if you are using a lot of hard drive space, you should know that. So to monitoring resources, there are 3 resources that you need to monitor in your system. That is disk space, processors or CPU that are being used, and RAM memory, because it's the 3 most important part of the system. So you are asking how much disk space do I have available, and you can run the command now if you want. You can type df. Okay, so df space dash LH is going to tell you how much space do you have. So you have different partitions. So partitions are location of sectors that has been divided in your system. Can be physical or virtual. We are not going to enter to that. So size is going to tell you how big are they. Use it, how much are you using from that, and available, how much of this space is available. And then use is the percentage of the use of those. The thing that is going to be important for you is going to be the one that say mounted on storage, because your home directory is in storage. That is df. If you want to specifically know how much this space is being used for a directory, not for in the whole system, but for a directory, instead df, you type du. So if, for example, you type in your directory du space dash lh, it's going to tell you how much space are you using in the system. Okay, that is this space. How about processors? So you have 2 important commands. The first one is top. So you type top in you will see that you open a new screen with a lot of lines, a lot of processors running. You can go out of this screen with just pushing Q, okay? And top is giving you a lot of different information. So you have a header first that is going to tell you, for example, for how long the system has been running, okay? How many users have been logged, how many tasks has been run, and how many of them are already running, for example, and then the use of the CPUs and the use of the memory and the use of the swap memory. I'm not going to talk about the swap memory now, but maybe this afternoon. And then after the header, you will see a lot of columns that are moving going forward because this is a dynamic process. And it's going to tell you the PID, that is the process ID, the user that is running the process, a lot of different columns that the most important ones for you is going to be the percentage of the CPU that is being used and how much memory are you using. And then for how long this has been running. And finally, what is the application or the program that is using. So for example, if I'm running a program, you should see my name here and then the command I'm using. That is in a dynamic way. You don't want to do it in a dynamic way. Other option is to type ps space aux, and it's going to print on the screen what are the process that has been running. Okay. Last one is memory. Okay. So so the last is with memory. So you want to know how much memory has the system and how much we use. You can use the command free space mem space -g, and it's going to print the memory in the system. So the system that you are running or that you are going to access has 3 terabytes of RAM memory. Okay, it's a server that is being used for genome assemblies, so it's a plenty of memory. And by the way, it has something like 160 threads. Okay, so can run 160 processes in parallel. Okay, that is for monitoring resources. Last thing, networking. For networking, don't worry because you are going to use FileZilla to exchange files. Okay, so this is just if at some point you need to access to the system or to other systems. So there are several commands that are important. First one is ping. So you are in a system and you don't know you have a connection. You type ping and then an address. Of course, because you are accessing already to this system in a remote way, means that the system has connection, because otherwise you will not be able to access. So in this case, you can avoid that. The second is SSH. So SSH is to log into a remote system, okay? And works like SSH, the name, ads, and the server name. So you have a terminal in a Mac, probably you are accessing the server just using this. Okay. You can specify the port, but by default, SSH use port 22. SCP is to copy files between different systems. And as I said, don't worry because you will be using FileZilla. If you want to use this command, it will be something like cp, the name, the username, and the address of the system that you want to do, and then where the file is located in the system, and then what is the local location that you want to copy to the file. Okay, so this is a file from a host to your computer, or from your computer to the host, you just switch the same thing, no? cp, the location of the file, and then where you want to copy the file. Just specifying again, username, ads, and the address of the system. The last important command, there are 2, is to retrieve things from a FTP site, and you will use wget in one of the exercises, is to download a file from a public site, so it's wget and then the location of the file. That will be one option. Or curl, that could be an interesting one, if you want to copy the file and then pipe the file into a different thing, okay? So that will be an example. In most of the cases, you will use wget. Final thing, final notes, installing programs. So there are several ways to install programs in Linux. One of them is to use package managers, and you have different levels. So in the easy way, you have graphical interfaces, or then you have applications that are going to go to some place, download the code and then install it, or you have a low-level command that is not going to download the code for you, but is going to install it in the system. That means move the files, compile some programs and move the files to different locations. That is using package managers, or the other will be moving executable files to the path, either pre-compiled files or compiling them from source and then moving to the right location. So for more complex system that you need to do less, to the less complex will be that. No, so the perfect case scenario, you have a program that you click a button and say install this, and you forget about anything else. And the last one is you need to download the files, running some programs to compile them, to make them executable, and then copy this executable to specific locations, including the library. So that can be very complex. Okay. Final thing, if you are going to read some files, something about Linux, yeah, there are some books, especially I use online resources, but that is okay. So that is for the Linux class. I'm going to stop the recording of this now. Okay.